Welcome to the Real Python Podcast. This is episode 42. Are you familiar with the role data engineers play in the modern landscape of data science and Python? Data engineering is a subdiscipline that focuses on the transportation, transformation, and storage of data. This week on the show, David Amos is back, and he's brought another batch of PyCoders Weekly articles and projects. Along with the Real Python article on data engineering, we talk about a project where researchers downloaded 10 million Jupyter notebooks from Github to gather insights about the current state of data science technology. We also discuss an article about validating data in Python with the package Cerberus. And this led us to a conversation about a set of coding challenges from Advent of Code. We also cover several other articles and projects from the Python community, including building your own chess engine, the visual guide to NumPy, a free and open source alternative to SAP, a library for working with STL files and 3D objects, and is Python really a bottleneck? Okay, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back.
Hey, Chris. Thanks for having me back.
It's a new year. Got a new set of articles and projects to talk about this week. Got a fun batch of stuff.
Yeah.
So I want to start off talking about a Real Python article. This is by our guest who was, joined us a few weeks ago, Kyle Stratus.
Mm-hmm.
Kyle was on also an early episode talking about finding another job during the pandemic. He has a real background in this. Actually, I saw him posting on Twitter recently about being a generalist, and I thought, oh my gosh, that's really a good definition of like what I am. I am such a generalist in so many different areas, and it just really is a good description. He had this book talking about it, so I'll include a link for that. But his article is about, it's less pure Python and more describing roles for jobs and so forth in our industry, and it's titled, "What is Data Engineering, and is it right for you?" The article really goes into describing the whole discipline of what is data engineering. People maybe have heard of like managing data or databases and so forth. And it feels like a term that needs to be defined a little bit compared to like what a data scientist is compared to what's happening there. He goes into the article and really dives deep into what does a data engineer do. And one of the main things that they're in charge of is this idea of a data pipeline. Data that's coming into an organization can be so varied. It can be, sensor data from vehicles. It can be sensor data, like the healthcare industry. It can be coming in at various tempos and could be very sporadic and coming out of different resources and inputs. And then the one that I'm most familiar with is financial data, it coming from lots of different systems, kind of coming in internally or externally and so forth. And so, you got to know where the data is coming from and sort of the cadence of it. He goes in and talks a little bit about this idea that a lot of programmers might have heard of a model view controller setup, or MVC. Mm-hmm. Where this sort of fits in is that the data engineer's job is to really build this model of the data, to organize it and shape it into a usable thing. So somebody like a business intelligence person or somebody who does visualizations on top of that needs that organized data, and hopefully it won't be just their job to gather and clean everything and make it all ready to go. And so that model of data and organizing it is really where this data engineer role kind of fits in. And then it goes into diving into talking about like what are the customers that you will be working with, and those are mostly internal customers. I think you would think about like within your organization, but there can also be outside customers if you're serving data as some sort of service in another way. And then it goes through the data flow. There's a lot of terms that are, acronyms that people throw around. If you look at like people's resumes or job listings, they might mention something called ETL, which stands for extract, transform, and load. That's part of that whole data flow. The extracting is bringing in all the data from these different sources and wrangling it in a certain way. And then transforming it involves potentially the whole thing of like normalizing it,
Mm-hmm.
like maybe it's removing duplicates. It's going to possibly be transforming it and making sense in maybe it's date information and it's incomplete and it needs to be in your specific format for that. So that might be a form of cleaning or optimizing missing fields, errors, or potentially corrupt data. And the last is then to load it up and put it into whatever the format of the database that's in there. So it goes really deep into all that stuff, which I think is really cool. I did a lot of this. I worked in a couple different roles. I know I've talked about the marketing role that I had, but the role I had before that was called credit risk. And so we were bringing in and analyzing all the different loans that are being processed through the system, everything from like auto loans to mortgages to credit cards and so forth. We needed to make sure that data was clean and prepared. And for whatever reason, in the process of doing that, I was mostly the person reporting on it, but we had become a part of the wheel in the cog where this whole machine where my job was to make sure that all these things were, appropriately formatted. So we had all these reports I'd run at the top of the month to basically make sure everything was, correctly inputted and find weird formatted things or, something's put in as text that it's supposed to be an integer.
Yeah.
And I wasn't using anything, advanced. It would have been awesome to have much more automated tools and use like Python, which is what really is a great tool for doing a lot of this. But I'm familiar with all the concepts and what needs to happen before you can ever report on what you have here.
Yeah.
And then he talks a lot about the common data engineering skills that you would need, general programming types of skills, everything from object-oriented, the idea that, you're kind of creating this structural language that the data needs to fit into with data structures, and then being familiar with the database technologies. And they could be the ones that we've talked about on the show a lot, the SQL-based ones with relational databases, but also there's, popular ones for other types of data that comes in, like the NoSQL type that are more sort of document-based and not really table-based type of relationships that you have. And then there's a variety of other ones that are interesting for speeding up and creating indexes and things like Redis and tools like that. And then you also need to be familiar with some of the other technology that's out there, like cloud engineering. Probably most importantly, at the very end of it, he talks about like what isn't data engineering, and it really isn't data science. That's something that really sort of happens after the fact, after the data is in this format that is ready to be consumed.
Right.
Now you're going to be trying to like figure out and create your models and build stuff on top of it, or business intelligence, which I talked a little bit about with like visualizations and charting the data, or even machine learning. And so it's such a crucial part of the whole flow, and it actually kind of lends itself to somebody who is a generalist in a way, somebody who is maybe has the background in some of these other areas that knows what these other teams are going to need. I was working at that same bank where I was working in the credit risk area, and I had worked in mortgages before that, and they were building a data warehouse, this separate team. And they were constantly asking us questions because they were the ones trying to model this stuff, but they didn't ever have to work with it. And so they didn't understand how it should be laid out or organized, or what makes sense, what sort of cadence should be stored. And they were trying to, data warehouses very often can like pre-bake attributes and things inside of there to make it easier and aggregate things so you're not having to do raw searches all the time. And the problem is they really had no idea what kinds of things that we would want to report on. So there's always this communication between teams, and having a generalist can really be useful there. It's definitely what Kyle's kind of slid into as his role over the last several years coming out of academia.
Yeah, I'm really glad to see this topic being discussed on Real Python, because I read an article a while ago. In fact, it may have even been like pre-2020, like in 2018, 2019, where they were talking about there were all these people that, data science had become like super popular, and there were all these people going to data science boot camps or getting data science master's degrees or things like that. And it was all very focused on machine learning, deep learning, neural networks, and, all that stuff. And when they were going out into the workforce, you had all these companies that were like, oh, I want to hire a data scientist because look at all the insights and, some of these big companies are getting from this. And so I want that for my company too. And they'd hire one of these people fresh out of school or something. And the realization was that the company that hired them was not in any position to be doing any machine learning, or they couldn't really get any insights from the data because it hadn't been normalized. It hadn't,
Right.
the whole process hadn't been done. And so you found these data scientists that were sort of thrown into a role where they really needed to be a data engineer, but they didn't have the right background or anything for that. Because one of the things that Kyle talks about in his article is that, data engineering relies a lot on software engineering best practices. And so you take full advantage of things like version control and things like that. So there was this real disconnect between what companies wanted and what they actually needed.
Yeah, definitely.
And the people, to fill those roles. So, but it's such a crucial part of it, even if you're not doing any like real machine learning. I think just to even get to the point where you can trust the kinds of insights that you get from your data, you have to start from data engineering. It's the absolute like first step to all of that. So anyways, so I'm just excited to see that. I think there's going to be more stuff coming out on that topic as well, where it actually gets into examples and showing you how to actually do some of this stuff. Because this article is I don't think there's even a single Python code block in it. It's just describing what data engineering is, what it isn't, and things like that. So, but yeah, really good stuff.
Yeah, I'm excited to see the kinds of things that you could add on top of it, and just even the practice of cleaning data and so forth.
Mm-hmm.
Very often the data that is presented in tutorials is always so pure,
right?
Even the stuff that comes from like different challenges and things out on the net, the data sources are all like, pre-organized, which is, is such an interesting skill on top of it. And it isn't. Nope. So
you come to these companies that have like, 10, 15 years of history with,
and different
spreadsheets
platforms.
It's like,
it's crazy.
It can be pretty overwhelming. Yeah. But that's the reality.
So what do you got first here?
My first article is called Building My Own Chess Engine, and it's not mine. It's written by Andrew Healy. It's about creating his own chess engine to play chess using Python. So he says he's been learning chess again, and he decided how to learn how to program a chess engine for the first time. And I wonder if it's related to the Queen's Gambit. I think that's...
Yeah. No. It's such a popular thing right now.
Yeah, and I saw someone post like, I think it was like a Google Trends like thing where like chess is basically just like shot up after that movie came out and everything. But
you can't buy a kit. It's like the same kind of idea. Like you couldn't buy a microphone or a lighting rig for all the video and audio cameras for computers are impossible to get too, right?
Right. So. Yeah. Yeah. It's funny. He says that after skimming some introductory text, he was convinced that building a simple chess engine, one that would put up a fair fight against a casual player, would take no more than a few days. But he was wrong. So it's, I think this is going to be like kind of a series that he's going to, kind of continue to talk about this. But he basically, in this article, he just talks about like kind of his general approach to it.
Yeah.
And some of like the things that he ran into really quickly. It was like, wow, okay, that's way more difficult than I expected it to be. For example, chess is such a beautiful and classic example of something called a combinatorial explosion. There's actually a very famous number associated with chess called the Shannon number. There's a mathematician named Claude Shannon who calculated that there's about 10 to the 120 possible games of chess. So it's one of those things that's weird. Like chess is finite. Like there's only so many combinations that you can get out of these pieces and moves, which means that at some point, there's only a finite number of like games that can happen. Like it's not it's a huge number though. I mean, 10 to the 120 is absolutely massive.
Right.
But, dealing with this thing, like the author, Andrew, when he was thinking about like, okay, how do I search for optimal moves and things like that? He started to realize that, okay, for the first move, there's something, I think it's like a few hundred possible moves for the first move. And so that's a pretty quick search when you're trying to find like of those 400 possible moves, what's the optimal one, right? Like if your opponent's already moved. Then after that, it starts getting into the thousands. And then by the third one, it's already up into the millions and it just is like exploding. And so by the time you get like a few, just, a half a dozen or so moves into the game, the the time that it takes to search through that tree of possible moves, staggering. You can't, I mean, how do you deal with that? It's going to take forever. So he really had to dig deep into algorithms and things like that to figure out, how do you deal with something like this? And he came down to using what's called the minimax search algorithm. And so he talks about how that algorithm works and how using tree data structures was something that was optimal for him here, and some different things that he had to learn to do with that. So it's a really good introduction, I guess, to like why it's good to study algorithms and data structures in the first place, because they can come up in somewhat surprising places.
Yeah.
I think if you have any background in like math or anything like that, you probably realize, well, it's not surprising that this came up in chess. But, I think that it seems like a relatively simple game. There's very strict rules. Like there's not a lot of things that can, like it just, things happen. Everything's kind of predetermined, right? And so, but you end up with this giant combinatorial explosion. Anyways, it's a fun article. Like I said, I think he's going to continue writing about this, kind of keep track of how things are going. So if you like it and are interested, you can follow along and see where he goes with it.
I like the resources at the end too, that he's including to different tools that he's looked at to kind of get him kickstarted and in the direction of doing it. And
yeah, exactly.
I've always thought about that in programming a game. The hardest part, I think, initially would be if you're going to make it a player versus the computer kind of thing, that programming of the moves and so forth to provide some form of intelligence at all to that opponent, to make it like interesting, is definitely an interesting challenge. And chess, like you said, with the combinations, it gets extremely interesting. And then having a machine that can look into the multiple of moves ahead.
So there's something else related to this about this, like creating games, that I just realized, and unfortunately I don't have. I think it was a tweet where I saw this. It was on Twitter, but someone had found the source code for like an old chess game written by Apple. And there was a note, there was a comment. And did you see this?
That. Yes, I thought that was hilarious.
About how they included like some time, just like waiting time on the computer, where it's like, just like tell it to wait for a little bit before it does anything.
Make it look like it's thinking.
To make it look like it's thinking, because it turns out people were like, get really frustrated when they realize like how quickly the computer can just...
It just makes them feel sad.
Beat them at chess. Yeah.
I'm so sad.
So something to take into consideration if you're making games.
Yeah, totally. Yeah, I think if it made instant moves just the minute you let go of your finger off your move would be pretty frustrating. So
absolutely, yeah.
I thought that was funny. I'll try to include that. Okay, well, my next one is interesting research project by the people at JetBrains. JetBrains make a very popular editor called PyCharm, along with all these other programs for developers. They have a new tool called Datalore, which is very interesting, which is a Jupyter notebook sort of hosted platform that they have. Mm-hmm. Over the last 3 years, they've been looking at, okay, well, what if we looked at all the different Jupyter notebooks that are published on GitHub? 2 years ago, the number was, I don't know, I guess you could say semi-manageable, because it was like 1,230,000 that they could kind of look at that were on GitHub. But by October of this year, it was almost up to 10 million. It was 9,720,000 notebooks. So it had grown quite a bit in 2 years, which kind of makes sense in some ways.
Yeah.
But they wanted to have an idea, okay, well, and they provide this data. If you'd like to go through and do your own kind of analysis and look at what they got from their data set, you can definitely do that. And then they wanted to see, okay, well, let's look at the figures. What is the language that data scientists are using? Jupyter notebooks, if you're not familiar with it, the JU is from Julia, which is another programming language. The Pi is obviously from Python. And the R at the end is the R programming language, which is popular out there also. And so when they looked at the numbers, it was shocking, the number of Python notebooks compared to everything else.
Yeah.
It was close to 8 million of them. And it's the growth there is pretty shocking. And then there was an interesting split between Python 2 and Python 3. In their 2018 research, it was 52 to 43%, with Python 2 having the lead at the time. And then it pretty quickly switched down to 18% Python 2 to 72% last year, and then down around 11%. Again, some of these are existing, notebooks that were there, but the Python 3 is at like 79, almost 80% of the total. And then other languages in some ways kind of increased somewhat to like about 10%. They were down in the like 4% before. So yeah, and then the versions of Python are kind of interesting. A lot of Python 3.6 and 3.7, a little bit of 3.8, not as much yet. So like all the versions of Python 3 in there, kind of interesting. And then R is like these tiny little slivers down at the bottom.
Yeah.
So then they wanted to look at the data science libraries, and they wanted to see what were people using inside these and what were they importing. And using NumPy is the most popular out of that batch. About 59% of them had NumPy.
Yeah.
And 47% had pandas, and then matplotlib, and then sklearn. And it kind of goes on down from there. It's very interesting to look at and kind of see. And then what I thought was an interesting analysis that they did after that was this idea of combinations of packages, which you might call like an environment, like what are you working inside of? And so pandas and NumPy is the most popular sort of combination of two. And then there were two that were pandas by itself or NumPy by itself. And then the next big stack is actually a combination of Seaborn, sklearn, pandas, NumPy, and matplotlib.
Yeah.
And then other interesting ones after that. But that one is actually pretty large combination. So that seems to be a popular combo. And then people are doing research with PyTorch versus TensorFlow, and they do that kind of combination. And then they start to look at like Markdown versus code. So how are people documenting, and how popular is that inside of that? And they're using a lot of Markdown is what was interesting. And at least 50% of the notebooks have at least or contain fewer than 4 Markdown cells, and around 66 code cells. But in general, about 70% have some form of Markdown inside of them. Interesting kind of research if you're interested in looking at like kind of what's happening out there in the world. Like I know a lot of surveys happen of like who's using what and where as far as the languages go, and then this is kind of diving deeper into some of the tools and might give you an idea if you're looking to get into data science, like, well, these are what are the popular tools that people are using, and understanding what might be useful to kind of look at and research. And then again, really useful that you can kind of go on, and they have a data lore notebook that you can kind of play in and check out the data yourself and mess around with it.
Yeah. What I thought was the most fascinating stat from that, and that is the whole consistency of notebooks thing, because this was really shocking to me. Because to me, like the whole idea, so the sort of the idea of a Jupyter notebook comes from this idea of or this notion of literate programming, right?
You're right. This is very interesting. Yeah.
Where you're like telling a story with your code, and you can literally just put in, like, that's what the Markdown is there. Like you can add that context to everything, and you can have these blocks of text between, and everything goes in a very linear order.
Right.
And that's why you have, like in Jupyter Notebook and things like that, you can just run a notebook from top to bottom. Like it just executes everything in linear order. And there's not a lot of, like within the notebooks themselves, there's not a lot of, I mean, things have probably changed, and maybe there's some of this now, but it used to be, it was like a notebook was sort of like a self-contained thing. I mean, you'd import libraries to use and everything, but you wouldn't really have like a project of notebooks that were all like importing things from each other and things like that. It's like a notebook is just, it's like, there it is. This is your notebook for this one thing. And like, yeah. And so what they found in this study was that, well, they started finding some Jupyter notebooks that could not be reproduced
right
linearly.
If you went linearly, yeah. If you try to play it, say, cell by cell, because they have those numbers that are there that indicate like what order,
right?
The state it was left in, if you will.
Exactly.
Yeah.
And they found that 36% of the notebooks that they investigated fell into this category of like not being able to be reproduced linearly, which was way more. I mean, that's over a third of the notebooks. That was way more than I would have expected. I assumed there would be some, right? I mean, there's always going to be something like that, but I thought it would be like less than 10%. I was just shocked that it was 36%.
Right. Somebody just kind of fooling around and decide to save it.
Right. Yeah, exactly.
On GitHub anyway.
Yeah.
That's pretty crazy. Yeah. There's a talk that was given by a data scientist, and he really likes Jupyter notebooks for one reason, but then he really hates them for another. And he was at a data science conference and he gave this talk, and he's basically was saying, why he thinks Jupyter notebooks are kind of bad. And he expected to get like booed off the stage when he started doing his presentation, to all these groups. And his problem was that you don't have this consistent state.
Yeah.
That you can run cells in whatever order, and you don't have a real idea of like what state all your variables are in, what, your data frames are in, and that the fact that you can do everything in this weird kind of, not weird, but you can do it in a exploratory fashion is powerful, but yet also really dangerous. And you can leave things in a non-reproducible state, like as you're stating, which is, not fantastic.
Yeah.
It's like you'd have to like leave instructions saying, well, skip these, cells, like turn them off and,
right. Yeah.
And then move ahead to the stuff, it's kind of I guess that's the way notebooks can be. Like people leave things in as, this is completely weird and unrelated, but I've been playing this video game called Control, and you enter this laboratory when you're trying to figure out what the scientists did before that, and there's like these boards everywhere, and they're like crossed out, and you're supposed to be like putting these things in these punch cards into these different computers to run something in a certain order, and they have like all these symbols, and then they're crossing out certain ones in what order they're in, and then like underneath it, if you don't really pay attention, there's little arrows that are indicating, oh, you should swap this one with that one, even though it's like drawn in a certain order on the board. So it's just funny. It's like, that's how science can be, right? Like you can kind of like have to kind of add notes to it. But the idea of state is really kind of interesting. I have a conversation that's coming out next episode with Nir from Jupyter, and the reason that he picked Jupyter notebooks is because he likes that live experimentation kind of idea that you can kind of throw code and execute as you go. And I totally see that, as a musician, as a creative person, and so forth. But I also see it from a developer standpoint or a sharing sort of standpoint that could be, dangerous, depending on, what order things are supposed to be in and understanding it. So like the minute you get to the point of, sharing your code, and a lot of these, I would say these projects probably weren't entirely, the idea wasn't necessarily it to be. Right. But anyway, it's interesting to think about. Yeah.
Yeah. I mean, I guess that is one of the things too. It's like, a lot of these projects were probably like, they needed a few plots.
Yeah.
And they got them, and then they, saved those as files and then put them in a report somewhere. And then now the notebook's just sitting there on GitHub, like,
right,
collecting dust and probably never going to be looked at it again.
Yeah.
But, but it is, it just was shocking. I just was like, wow, that is not what I expected.
Yeah.
And there's a really fascinating graph about this where they show that the smaller the number of cells there were in a notebook, the more likely it was to be consistent.
Yeah.
But as that number of cells got greater than, so once you get up above, what is it, like maybe like around 16 or 17 cells,
it starts to get hairy.
it's actually more likely to be inconsistent than it is consistent. Yeah. Anyways, just a really fascinating article. It was a really cool idea, I think.
I'm glad they're ongoing. The fact that they have multiple points on the curve too is actually very cool.
Yeah, for sure.
This week, I want to shine a spotlight on another Real Python video course. It's a brand new course. It's an advanced web development course for those who want to take working with Django further, and it's titled Building with Django REST Framework. This course was created and presented by previous guest Christopher Trudeau. In the course, you'll learn about the REST protocol, Django REST Framework serializers, and how to use them with Django objects, using Django views and DRF viewset classes to create REST endpoints, multiple flavors of renderers and how to control their output, specifying permissions and limiting who can see what data in your REST API. This is an advanced course, but if you're interested in learning the topic, several prerequisite RealPython courses and articles are shared at the beginning. The course includes code samples to check your work along the way. And like most of the video courses on RealPython, the course is broken into easily consumable sections with a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. So what do you got next?
The next one I've got is called Is Python Really a Bottleneck? And it's an opinion article by Anna Anasenia. And the subtitle is, I'm tired of articles about Python dying.
Yeah.
So she basically just tackles this question. And there's been a lot of articles written about this. And, she says, the question is Python too slow? And I think she has a really interesting perspective on it, because She is a data engineer, going back to your first article from Kyle.
Yeah.
She has a master's in business intelligence. So, she's in this data science, data engineering world. And I hadn't really seen any discussions of it from that perspective. And that's an area where speed can be absolutely key, right? Especially if you're doing something with like really large numbers of like big data, something like that. And so, she says, like, is Python slow in crunching numbers compared to compiled languages like C? Yes, it is. That's a fact that's been known for years. That's why we have libraries like NumPy that leverage C under the hood. But is Python that much slower than other, more difficult to learn and use languages for all use cases? And her answer there is, well, I don't think so. She does have some kind of web framework benchmarks that she mentions and comparing speed to things. But basically, she says that it really comes down to code speed versus practicality. So from a pragmatic standpoint, there are many different questions that need to be answered when you're choosing a programming language for day-to-day work. And she lists off some of those questions. And those are, can you reliably solve multiple business problems with this language? Can you find enough employees that know this language?
Yeah.
What are the synergies between experts from different domains? And what are the true bottlenecks in data processing? So she talks about things like writing to relational databases, making calls to external APIs, working with big data. Those are the bottlenecks. It's not really like the speed, like the computational speed of things. You're losing more of your time in the database calls and the external APIs and that kind of stuff.
Yeah, definitely.
That's not going to change depending on what language you use. Those things are still going to be bottlenecks, regardless of whether you're using Python, you're using R, you're using C, you're using Java, like whatever it is, like those things are still going to be issues. And so you might as well pick a language that's going to be easy to work with. You can find lots of people that know it and is going to help you get your product out more quickly and more efficiently. So it's a good opinion piece. And the thing that I really liked about it, again, was just that it was written from sort of this data engineering perspective. Because it seems like most of the articles I've seen on this are always written from like a web development. They're really focused on like web applications or things like that, and not so much coming from the data space. So
it makes me think about the interview I had with Brett Slatkin from Google.
Yeah.
And how in his space of creating all these tools, his biggest bottleneck was always the sort of development time and getting something up on its feet and having it up and running. And he needed it, like right away, in these different environments. And so Python has always been his favorite tool for that. And I could definitely see that. Like, it's not always necessarily, if you're running an audio engine or something like that, potentially, or you're doing some other kind of thing where the actual processing graphics or some kind of like other kind of C-level type of thing where it makes sense that that's going to be really useful.
Yeah.
But generally, the types of things that we're solving in day-to-day jobs in huge time amount is the coming up with the solution,
right,
or getting the data ready, or like all those different things. So I think that's a really good kind of point to kind of focus on all of it. And I feel like a lot of people don't calculate the development time or just even like the comprehension time. There's so much turnover in workplaces, and Python being a very popular language is helpful, but also just the readability and the ability to look at the code and see what's going on.
Yeah.
It's definitely a huge factor, I think, too, to get other people up to being able to, build on top of what you've already have, or just to understand what the code base is doing.
Yeah, exactly.
So my next one is kind of an interesting combination of things. I haven't started this myself. Have you done Advent of Code before?
I have not, actually. I usually don't have time for those kinds of things.
Yeah. Well, I kept seeing it around this year and was kind of passing around the Real Python Slack channels and so forth. And I saw different people doing it, and it's a yearly event. Mm-hmm. This programmer, Eric Wassel, I'm guessing is maybe how to pronounce his last name. And he has it trademarked. The Advent of Code is trademarked under his name. But the idea is, starting the month of December, he puts up like 25 examples. And this kind of goes back to something we've talked about of practice problems. And then I had Reuven on recently, and this idea of like having things to keep sharpening your saw as a programmer, like maybe simple problems that you don't know that you can kind of try to puzzle out through your code. And it's been going on for 6 years. It started in 2015. I'll include links to it, and you can, just peruse it. And the idea isn't language specific, which is kind of cool. You could be, trying to solve these things in Java or JavaScript or Python or, whatever language that makes sense to you. The idea here is this problem, and it gives you a way to like submit code and so forth. But why I went down that rabbit hole is there was this article about validating data. And one of the projects, I think the fourth one for 2020, it's about validating data. The data was sort of laid out kind of like it would be for passports. And so there's this set of data that's kind of mixed up, and it kind of goes back to the data engineering thing that you need to kind of find out like, okay, what are valid passports and what are not? And so this developer wrote this article, and the title of it is Validating Data in Python with Cerberus. And Cerberus is a Python library. It's a lightweight extensible data validation library for Python. And I'll include the GitHub for that so you can check it out. But the idea is that it can go through and you can set up a set of rules. It's written in Python, so it's fairly easy to understand, but you can go through and say, I want to validate this dictionary of data coming in and, based upon these rules. And the sets of rules are kind of cool. Like you can have it validate a variety of sort of schema kind of stuff that you look at. Like, okay, I want to have it look at using, it could be any of these particular very specific values. You can set up minimums and maximums. You can set up regular expression, kind of true, false kind of things. Does it fit in this regular expression? A couple of them might require multiple. Like one of them, it's, looking at height, but the height could be in inches or it could be in centimeters. And so first thing was like, let's look to make sure as a regular expression that this, fits this mode. And then from there, then look at the range to see what it fits in. And the code actually that he created is actually pretty slick. It's, pretty simple solution to this problem. It's just kind of nice to see the thought process going into it. And then to have a library that you might find useful to go through and clean and validate your own data that's coming in, which is again, part of that whole data engineering part. You'd wish that all your data was perfect, but unfortunately humans, right? Nice. So, or in this case, it could be, countries, right? The orders of the fields will be different. The units are going to be different and things like that.
Yeah.
I don't know. I liked it. It was a neat little article. It helped me kind of dive a little deeper into what the advent of code is. And if you are looking for more challenges and stuff like that, it's, free to check out. And so I'll include links to not only the article and the library, but you can kind of look at the several years of examples and practice problems for yourself.
Yeah, advent of code I know has become pretty popular. I think that it starts relatively easy.
Yeah, they kind of ramp up a little bit.
And then it starts to ramp up. Yeah, and I think that last year I remember there was a problem. I saw this like all over Twitter and people posting in Slack and everything that there was some problem that had to do with some like pathfinding problem.
Oh, okay.
That was like really, really hard. Like it got really difficult really quickly or something like that. So yeah, but it is a cool thing. It's every year they do that. And yeah, if you're into the code challenges and looking for something, did you check? Do they have like the archives? Can you go back and? Yeah,
that's what I did. I went and dove back. Yeah, you can go and see back to 2015.
Gotcha. Yeah.
So six full years at this point.
Yeah.
The author of the article is Hector Castro. That's who wrote the validating data, and it's a nice short read. It's a couple minutes to check it out, but it introduced me to that nice library. So
yeah, for sure. Thanks, Hector.
What do you got? What do you got next?
The next one on my list is called NumPy Illustrated, the Visual Guide to NumPy. This is from Lev Maximov, and it's actually like built on top of another article called A Visual Intro to NumPy and Data Representation by Jay Alomar.
Okay.
That was written back in, June of 2019. So it's an older one, and it's kind of it's not real short. It's is an introduction to like how data is represented in arrays and how these array operations work and things like that. And it's a very visual, there's just tons of visual aids.
Yeah.
So if you're a visual learner, it's a really great resource for just sort of visually visualizing what is going on when you do things like taking dot products of matrices, or how indexing works and what happens when you reshape things and all this kind of stuff, and start getting into bigger, larger dimensions and all this stuff here. So that's Jay Alamar's. What Lev did was, I guess he really liked that visual style of learning and found it really helpful. So he just decided to just take it to the next level. His quote here is, he says, "I took a great article, A Visual Intro to NumPy by Jay Alamar, as a starting point, significantly expanded its coverage," and there's lots of emphasis on significantly, "and amended a pair of nuances." So the article is way bigger. It's really long, but it's just meant to be like a resource, right? Like you would just search through this to find the things that you are interested in, or I don't think it's necessarily meant like you don't have to read it sequentially. It's kind of just encyclopedia kind of thing.
Yeah, like nice visual reference to go back to.
Yeah, exactly. But again, it's got just a ton of visual aids. He even kind of kept the style a little bit. Like if you compare the two articles, the visual aids sort of have, similar style.
Yeah.
Yeah. He's just expanded on it. He gets into how to deal with one-dimensional arrays and two-dimensional arrays, and then looking at 3D and above. He looks at all the different methods, how you combine and manipulate these arrays. And I mean, it's just incredibly thorough. I mean, NumPy is a huge library, so it doesn't cover all of NumPy, but it's a really good starting point if you're just learning NumPy, or if you know it but you don't feel like you have mastered it. Then I would recommend taking a look at this, just because it's so different from reading the documentation or reading even like a tutorial. It's like it's a totally different way of looking at it, and that may really resonate with you. I think it's an excellent resource. Yeah, I would highly recommend that people check this out that are interested in learning about NumPy.
I think I mentioned before somewhere in here, I'm not a huge fan of the pandas documentation, partly because it is just seems really common that the data is always just like a 1, 2, 3 ABC kind of stuff in every single example.
Right.
This adding the visual component to it, I think, helped to elevate that, like
Absolutely.
You can still have those simple examples in it, but if you graphically are showing me like the output of it, it starts to make more sense to be less of like just a numeric soup on the page,
Right.
And it kind of organizes it mentally. So yeah, that's cool. And I haven't looked at the NumPy documentation, but I would guess it would be similar to the pandas documentation as far as how it's laid out.
It's fairly similar. Yeah.
Nice. Well, it kind of gets us into projects. And we've talked before about reading other people's code.
Mm-hmm.
So when I saw this project come up on the PyCoders list, I was like, oh my gosh, wow. If you wanted to learn a lot and learn how to organize things and learn like how to tie all these things together, well, this might be a really good one for you. It's called erpnext. ERP, if you're not familiar with it, is kind of this combination of things from something called SAP, which I always kind of heard, and we were talking about this before we got going today, and you might have heard of SAP as like company, or maybe as a type of software that's out there, and it's the most generic acronym ever: systems, applications, and products.
Mm-hmm. Yeah.
And then the secondary ERP is enterprise resource planning. And so like, it's super, super generic, but like, basically what I think of is like, okay, the type of software that like an entire business runs off of,
right?
Where if you want to build a monolith and it needs to have, not only HR and payroll and, like a whole accounting thing and resource management and all these kind of different modular things that you may want to focus on, this is a huge monolith. Mm-hmm. And it's open source and it's Python, which is pretty amazing. It's built on their own engine called Frappe. And the Frappe engine is open source also. And then I noticed they have Docker images of some of this. So if you didn't want to have to try to set up entirely everything on your own, because it requires like a database also to kind of get things up and running, you can definitely do that. But if you wanted to have a look at what is involved, Frappe is their low code, sort of full stack web application framework. It uses Python and MariaDB, and it has, installation, documentation, licensing, the whole deal. Like you can kind of check out what's involved. It's sort of like Django in a sense that it's this huge framework of things that can kind of go in. It's not really like a lightweight thing, but what you can build on top of it, you could build like a help desk system. You could build a library system. You could build, all these different kinds of things, and huge amount of contributors to it. Frappe itself is like, 50% Python, and then quite a bit of JavaScript because it is sort of web based to be hosted.
Yeah.
But it's always kind of cool to see how all those things tie together. Like, how are they tying it to JavaScript? How are they talking back and forth to the database? All those kinds of things. And just, all the code is up here on GitHub. And to be able to see an entire system, erpnext, and, it's a commercial product also. As an organization, they offer it as a, tool that you can have, set up accounting, sales and purchase, CRM projects, all the way down to like a just website or something, or including all of those things, and it's pretty slick. So I think it's a good project to kind of get if you're interested in reading and kind of seeing software design and how a big monolith might be put together. It's a neat project to check out.
Yeah, exactly. That's I think one of the things that's cool about it is it's hard to find good examples of like big projects that you can just go and look at the code for. And so this is one of those. I mean, I'm just looking at it. It's got 2,410 Python files and like 1,200 JavaScript.
Yeah. erpnext is even more Python. Yeah. So 70% Python.
Yeah, exactly. Yeah, so it's just neat that that this is just open source. And so, because I know that's a really common question that I see from real Python members that are new to programming is, how should I organize my code?
Right.
How do I structure my project? If you're struggling with learning how to do that for a small project, I mean, just imagine trying to do that for like a really large project, right? I mean, even people who are good at organizing and structuring are going to struggle with that kind of stuff. So yeah, I think it's awesome that they've just put this out there, and anyone can go and study it, and of course use it if it's something that fits a need that you have. But I think the primary reason for including this was just to like, hey, here is an awesome example of like a really huge project.
Thing. Yeah.
So
like I just dove into one just because it was intriguing. So like, here's a module, hotels.
Yeah.
And it starts off with a directory called doc type, which is kind of the overall model structure, is this sort of idea of like a document that you're going to be sort of creating things inside of. And then inside of doc type, there's like amenities, package, pricing items, pricing package, reservation item, room type, and so forth, And so, like if you wanted to think about like, well, how would I model a help desk application? Here's an example where you can kind of, even if you're just looking at how they structurally, again, going back to data engineering, laid out the organization of this and what the documents kind of look like and what the forms look like. It's pretty slick. Definitely be a big area to dive in, and everything from manufacturing to hotels to quality management to restaurants to shopping carts, what have you. It's crazy.
Yeah, very, very big project that you can kind of check out. So what's your project? Project that I got this week is called numpy-stl, and this I found a small article, and we can link to the article. It's real short. It's just it's actually written by, I guess, someone who works as like a fabricator. It was just a little example of how you can use this numpy-stl to create something called an STL file, which is it's not I should say it's a file format for like 3D printing, 3D modeling, and fabrication. It was native to some company called 3D Systems for stereolithography CAD software. And interesting enough, looking up STL on Wikipedia, this is a total side note, but I learned what a backronym is. Have you ever heard of a backronym?
Where you make an acronym after the fact.
Yeah, so I guess like
yeah.
STL was already like they called it STL, but I don't know that it like stood for anything. So some people have now say that it's standard triangle language or standard tessellation language. Yeah. So yeah, after the fact, they've gone and filled in the phrase for the acronym. That's a backronym apparently. So
yeah, too funny.
New thing I learned. Yeah. But yeah, so that's these files sort of like define like a 3D model is like just a bunch of like triangles pieced together. So it's which should be called like a tessellation. What numpy-stl does, so STL is like it's sort of like its own little language. So it's like a domain specific language, and you define these things called facets, and you can use loops and stuff in it. But it's not a very efficient and optimized way of like storing this data, but it's just become kind of just used in a lot of places for historical reasons. But you end up with really long files basically for like large objects. It can be a real pain in the butt to have to type all that out. So numpy-stl allows you to define your objects as numpy arrays and using the power of numpy, and then generate that STL file for you, which is a lot easier than having to type it all out in this little STL language that they have. So if you're into 3D modeling or would like to get into 3D printing or just want to design something and have someone fabricate it for you, and you're a Python programmer and you know how to use NumPy, then numpy-stl has you covered. So I thought that was cool. It was sort of like just realizing, and we've talked about this before on the podcast, but how Python just shows up in places that you just never really think that like, oh yeah, they're using Python over there as, fabricators.
Yeah.
Like I would have guessed, right? But it's not, like a small project. I mean, it's being used by quite a few people. It's already got 334 stars on GitHub, which I know isn't like whoa, it's got thousands and thousands of stars or something. But I mean, for a project to get to 334 stars is pretty good. So yeah, so it's just neat to see. Here's another area where Python is helping to make lives a little bit easier, and as Mike Kennedy likes to say, giving people superpowers.
Yeah, no, it's cool. Like I was going to ask when I had the two teachers, Sean Tibor and Kelly on, I wanted to ask them about 3D printers because I know they use them, and Sean had to leave early, so I didn't get a chance to reach out to him and ask him.
Yeah.
But because I've been looking at them, I think I even mentioned it to Al Swigert. He said, yep, another thing that might sit in the corner and gather dust. I'm like, well, yeah. But I don't know. I have a few ideas of things I want to create, beyond like, little interesting trinkets and toys and things like that. I've been getting more into projects again, and just the idea of like, once you get into like an Arduino or these other kinds of things, even a Raspberry Pi, it's like the kind of like cases and other things, like places where you want to like mount that stuff and put it together. Like,
right.
3D printing just makes so much more sense.
Yeah.
So,
and I think one of the cool things about the 3D printing too is like it's made prototyping so much more accessible for people, right? Like,
oh yeah,
if you have a product idea, just even like 10, 15 years ago, getting a prototype made could be very costly and could be a barrier there. And now 3D printing, I mean, it's not like, well, unless you have a lot of money, but I think most people can't just like, I'm just going to go buy a 3D printer today. Like it's, but you've seen the price come down dramatically, and it kind of keeps coming down. But you've also now got, like, I know last year when I was at the PyTexas conference, it was at the Austin Public Library, this huge building, and they had like a whole room full of 3D printers that you could just come.
Yeah.
And I think you had to like maybe you had to like pay for the material, or you could provide your own material, but it was free for you to use the 3D printer. And I think there's places like that all over. So it's become really accessible. If you have product ideas, or if you're interested in coming up with something, a physical project, and need like a little case or little bits and bobs pieces that you need to kind of get your prototype put together, then yeah, I mean that stuff might be available to you depending on where you live. So, and numpy-stl can help you do the 3D modeling.
Yeah, help you with that. Yeah, no, it looks like it. Doing a little more research on it, I know I'd seen those files before, and it looks like it's still the sort of de facto standard out there. And
yeah,
awesome. Well, thanks again for coming on the show and sharing all those articles and projects with me again.
Yeah, thanks for hanging out and having me on.
All right, talk to you soon.
See you later.
I want to thank David Amos for coming on the show again, and I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey. I look forward to talking to you soon.